February evenings are a great time to look for some beautiful objects, star clusters. In this case, open or galactic clusters are what astronomers call them. If we go out and look for the winter oval, like we talked about last month, the Milky Way runs right through the winter oval, and just to the west of the winter oval is our first cluster. Lots of people see it. It's an eye-catching little thing called the Pleiades, or the Seven Sisters. Most of us can only see 6 there, but the mystery is not an astronomical one. There's probably 1,000 stars right there on the western edge of Taurus the Bull. If you get out a pair of binoculars, which is a really good way to enjoy all of these star clusters, and zoom in on the Pleiades, you'll see that there are quite a few more stars there than the naked eye is able to reveal. There's lots of open clusters up there. Not all of them have such brilliant young stars in them. The Pleiades is a fairly young cluster, probably only about 100 million years old. There's an older one just next door, which is also part of Taurus the Bull. This is the bull's head, this kind of V-shaped group of stars, which is called the Hyades, not counting that real bright one there, Aldebaran. The Hyades is an open cluster that's much closer to the sun, and so it looks bigger in the sky, but it similarly has probably 1,000 stars there. If we look over to the eastern side of the Milky Way, there's another constellation, the constellation of Cancer. A little bit harder to pick out than these other two objects, but right there between those two stars in Cancer, you can find what we call the Beehive cluster, or it's also called by its Latin name Praecipe, which means the manger. Here we have something of what you would see through binoculars if you looked up there at the Beehive cluster, which you can also look at with a low-power telescope. These clusters are, of course, three-dimensional objects, and we can best appreciate that with this nice piece of software called Digital Universe, a three-dimensional database of the stars in our galaxy. And we're flying right now out to the Hyades, about 150 light years away from the sun. If we pick a star out in the cluster, we can then orbit around it, and now we can begin to appreciate the three-dimensional distribution of the stars in the Hyades cluster, the one that looks like the V-shaped head of Taurus the Bull, Aldebaran not in there. In fact, there aren't any really bright stars in there. Those hot blue stars that we see in the Pleiades are notably absent. There's still probably 1,000 stars there, most of them rather dim ones that it would take a pretty big telescope even on Earth to see. If we center up now on the Pleiades, we can fly over there and visit the Seven Sisters, or more like the 1,000 Sisters over there. We have to go quite a bit farther. The Pleiades are about 3 times the distance of the Hyades from the Earth, about 450 light years away. Now, one of the reasons that it looks smaller, but despite that greater difference, those bright blue stars, those young stars, type B stars astronomers call them, stand out, and we see them coming into view here. In fact, they all have names, the ones that we can see from the Earth, the 6 that we can see with the unaided eye. We'll select one, and then we can use that point to orbit around the Pleiades now and get an idea of its general distribution in the sky. Again, remember, the vast majority of the stars are dim ones that aren't represented here in the simulation either. But this is such a beautiful object and well worth the time to go out, get the binoculars out, and just study the Pleiades for a little while. So now we'll head over to the Beehive cluster over there in Cancer and take a look. The Beehive cluster is still farther away from the Earth, about 600 light years away from our solar system. Similarly, about 1,000 stars in it, similar to the Hyades in a lot of ways, and in fact similar in age, about 500 million years, about 1/10 the age of the sun. The age and also the motion through the galaxy of these clusters makes a lot of astronomers think that the Hyades and the Beehive cluster might actually be related. One of the most interesting open clusters in the sky is in the Orion Nebula, where the open cluster is in the very process of forming. It's easy to find. Look for Orion in the winter sky, the belt, a well-known landmark, and then the sword or dagger, the 3 stars that hang from the belt. the middle star, even examined with the unaided eye, looks a little suspicious. And when you look at it with binoculars, you can see that the star is not really a star, but is extremely nebulous. That's the Great Orion Nebula, which astronomers have been fascinated by for centuries and has been very well studied. There we have a couple of thousand stars still in the nebula from which they form, the gas and dust cloud, the giant molecular cloud in which gravity draws the materials together until they form many, many stars, the most visible of which are some of the most luminous stars in the entire galaxy. To fly with Digital Universe over to the 2,000 stars of the Orion Nebula will take a little bit longer because we have to go twice as far, more than twice as far as over to the Beehive cluster. We have to fly about 1,300 light years over to the Orion Nebula. Deep inside the Orion Nebula are those young hot stars, and those are the ones whose light we can see even from Earth. And in a telescope, you can see them as the shape that astronomers call the trapezium. There they are, making sort of a trapezoidal kind of shape. And those are those O-type stars, the most massive, most brilliant stars that have very short lifetimes, that have formed out of the dust and gas, like all of the thousands of stars there. The dust and gas, the reddish glow there of the nebula, is not as well mapped in 3 dimensions, and so we'll turn that off so we can see the structure of the cluster itself better. The O-type stars that are in there, in the trapezium, and others will eventually be responsible for dispersing most of that material out of which stars are forming. Their intense ultraviolet light basically evaporates that material away, and when it's all gone, star formation stops, and you have a finished open cluster. And here we have it. You see how those young hot O stars in the center dominate. They'll only last a few million years, maybe 10 million years or so, before they use up their fuel and explode as supernovas. And the Orion Nebula will begin to look a lot more like the Pleiades. Get your binoculars out and take a look at the celestial jewel box while winter skies permit.